So if r and n are positive integers bigger than 1 and bigger than 2 respectively, and coefficients and what is this, like coefficient of r plus 2th term and the 3rth term in the expansion of 1 plus x power 2n are equal, then I think then n equals. Okay, so what's the coefficient of r plus 2th term? That will be n. Here you should have 2n instead of n, so 2n choose r plus 1, and this should be equal to the coefficient of the 3rth term, which will be, I think, 2n choose 3r minus 1. Okay, cool. So now we just need to simplify this, which is going to take quite a bit of time. Okay, so maybe we can just go through the options, maybe. uh okay, then n equals, right? You know what, let's just do it. In fact, let's just go through all the simplification and stuff. Or should we? If we go through all the simplification, we might not even get it. So what can it be equal to? Can you have n equal to um 2r plus 1? That would be like 4r plus 1 stuff. Maybe we should just go through it. Okay, so yeah, we are gonna go through it. So it's going to be 2n factorial, and the reason why I was hesitating to go through it was that once I dealt with factorials and binomial coefficients being equal to some integer, and then I wanted to find the solutions, so it took me a whole bunch of casework to get to the solution, and that's why I try to ignore these problems. uh, but now just have to do it. So yeah, like 2n minus r minus 1 factorial, and over here you will have r plus 1 factorial. Okay, that is supposed to be equal to 2n factorial upon 2n minus 3r plus 1 factorial and 3r minus 1 factorial. Okay, cool. So yeah, that's gonna cancel. And what else do you have? I think you will have this thing, 2n minus 3r plus 1 factorial. Oh, so that's actually the smaller value, so maybe we should put that over there. So let's put that over there. So like 3r minus 1 factorial upon r plus 1 factorial. That is equal to 2n minus r minus 1 factorial upon 2n minus 3r plus 1 factorial. Okay, this looks scary. Okay, fine. Now what do we do? So we could try, maybe. Okay, so maybe we can actually do that thing, right? So we'll do that from r plus 2 onwards. Okay, that's gonna take some really big amount of time, uh, but whatever, just do it. Let's see what we get. So just if we somehow got lucky, and if I, I I think maybe we should go to the options, because yes, it does look like this is not going to be solvable, because first of all it's in two variables, and second of all it has a lot of multiplications, so it's not something which you can solve with standard number theory or stuff. uh yeah, so maybe we can solve this using inequalities, and maybe like using the fact that this is like increasing function in n. uh yeah, so after a certain point you won't get any solutions, because like the value of this 2n minus r minus 1 upon 2n minus r minus 1 factorial upon 2n minus 3r plus 1 factorial will be very big compared to this left hand side, and then it just keep on increasing. So what that means is that there will be at most one solution, and in fact exactly one solution, because uh, yeah, we have to find a solution, so it has to be at least that there's one solution. So let's just go through the options and see if any of these options will trivially satisfy this equation. So if I put the value of n as 3r, that will give me 3r minus 1 factorial upon r plus 1 factorial is equal to 6r minus r, which is 5r minus 1 factorial upon 3r plus 1 factor. Wait, that doesn't make sense. Yes, that doesn't make sense. Or you could have 3r plus 1. No, not gonna go through that stuff. Okay, or you could have 2r, which will give me 4r minus r, which is 3r minus 1 factorial. And then over here you just get r plus 1 factorial. Oh yes, that's it. So like n equals to, just by guessing you just get like n equals to 2r should be a solution, and in fact I assure you that it is the only solution, because this left hand side is always going to increase as we get to higher values of n. So yeah, n equals to 2r will be the only solution. Nothing else is going to work. Okay, so let's go to the third question. So the coefficients of x power p and x power q in the expansion of 1 plus x power p plus q are. So yeah, this is a very standard question. We know it, these are actually equal, right? So it should be like these are in fact equal. So it's going to be p plus q, choose p, and p plus q, choose q. So both of these coefficients are actually equal. So that's it. So I will see you in the next video.